welcome everyone. Let's start with a quick question for you. Who here goes to work by car? Raise your hand. Okay. Who goes to work by car? Okay. Who goes to work by bus or public transportation? There's no one here in Beirut. I think in Paris it would be different. Okay. Now the interesting question is, who goes to work on Skype? Okay. We have, okay. So I know Muhammad and Hisham, they are my team members, and they know what I'm talking about. So actually, in our team, we take Skype every day to work. And today, this is Philippe, by the way.
Hi. Hi, Philippe. Yes, sorry, today I couldn't make it to Beirut, but I'm happy to be with you through Skype. And in fact, it turned out to be a good idea to show you how we adopted XP to our distributed team.
Yeah, so today, Philippe and I will do a demonstration how do we work on a daily basis on extreme programming in a distributed mode. We're going to do two demos. One would be on a pair programming in a distributed mode as well, and some kind of remote retrospectives between office in Beirut and office in Paris. So if you're a software engineer who's interested in this, or who's willing to work for a remote office, or is currently working for a remote office, this presentation might be an interesting one for you. So before I start, I just want to let you know that the presentation is expected to take 50 minutes. Throughout the presentation, if you have any question, please log into this website and post your questions. And then by the end, we're going to take the most voted ones. So you also can vote for the questions you want to be answered. And you're going to see this link on the footer of each of the slides for this presentation. So let's start. Philippe, I'm going to introduce ourselves a bit. So Philippe, you want to start?
Yeah, sure. So I like to call me a happiness and productivity hacker. So that doesn't mean much, but it's kind of the things that interest me. Officially, I'm a software engineer, and currently I'm kind of a jack of all trades at Murex, developer, architect, manager, and agile coach in our risk engine team. I'm also a self-proclaimed change agent in the company, and I like to do side projects at night. And for this talk, I'm actually the remote buddy for Ahmad.
Thanks, Philippe. Just also to add to Philippe that he's our team's mentor, and actually he pushed me a lot during this year to do this presentation. So after I told him that I'm interested in that, we just kept on working together to do this presentation. So a bit about me. My name is Ahmad Atwi. I graduated from AUB in 2005. I started working then in the software engineering field. 8 years ago, I joined Murex. And on my spare time outside work, I read a lot of books. I do programming for fun, but I also am a scuba diver and a squash player. So we obviously, you obviously know that we both work for Murex. Murex is at the age of 30 now. It has been leading the financial market since 30 years ago. We're not going to discuss a lot about Murex because that's not the purpose of the presentation. Now, you can see here that there's an airplane engine, and you might be wondering, what do we have to do with that? Well, absolutely nothing. What we are doing is an engine, but a risk engine for the financial market. We are an R&D department, so we're not. Most of our work is confidential. We are not allowed to talk about it. So that's the only thing that I can say, which is a risk engine, and this is similar to an airplane engine. So I can talk more about the team. So actually, we're a team of 8, 5 of whom are based in Paris, and 3 are in Beirut. A couple of weeks ago, when I was preparing for this presentation, I asked the team to write a couple of words describing the team. So they came up with those words. The most important one, or the one we're going to discuss about more in details today, is the Agile extreme programmers. So we've mentioned extreme programming twice so far, or probably more. So what is it? Extreme programming is one of the Agile methodologies. Its rules can be grouped into 3 categories. We have the values, we have the principles, and we have the practices. If we're going to talk about each one of them, we're going to end like the full day talking. But for this one, we're just going to focus on the practices part. And that's why actually we called our presentation Extreme Practices, because they are the practices of the extreme programming.
Yeah, there's also something to note about XP. It's that it's totally guaranteed to be stress-free, and I promise that once you've tried it, you'll never want to go back again.
Yeah. I think we started doing that in our team 3.5 years ago, and we're still doing that. And I think more teams at Murex are starting to adopt this practice. So let's start with the practices of XP. One of the major rules of XP is the 10 minutes build. So we all know this image, which slacking or wasting your time waiting for your build to compile or to be completed. With XP, this is not the case anymore. One of the major rule is that your build should not exceed the 10 minutes. Why is that? Well, simply they say in the book because it's a good time for taking a coffee break. But there's even more for that. For example, you stay in the zone. So imagine yourself writing a complex algorithm, and then you run your compiler, but you had to wait for the 1 hour for the compiler to be done. So if you want to come back 1 hour later, it's obviously you're going to lose a lot of ideas, and you're going to lose track of where you were. Whereas if you have just a 10 minutes build, it would be easy just to take shorter breaks every now and then and continue from where you stopped. Another important point, which is the baby steps. And here we mean that when you have a shorter compile time, this will encourage you to do submits more frequently. And that's what we mean by baby steps. This will result in incremental design, incremental build, and easier way to find out bugs when they occur.
Yeah. Unfortunately, we stopped doing sort finds at work. So.
Yeah. It's harder to do it when we're in Beirut and you're in Paris, Philippe.
Yeah, anyway.
Yeah. So in our team, 10 minutes was too much. We dropped that to 3 minutes build. This is actually taken from one of our CIs, and you can see that there's no timing here, but trust me, the RTDB job takes 3 minutes, and actually 2 minutes, 28 seconds to be precise.
Yeah, but maybe we should go back to work and fix this integration test.
Yeah, I think Muhammad was doing the fix, and he was not here today. Well, there he is. Yesterday he was slacking. So the second principle is that test-driven development, or what TDD. Honestly, this topic, Philippe and I are giving a lot of practices or training on that at Murex, and we can spend hours talking about it. But what we want to say here is that with TDD, your development is driven by tests, and not the opposite way around. So you have 3 states of TDD. First, you start by writing your test. So the test at the initial state will fail because there is no code behind for that. And then you write the efficient code, and just the efficient code to make that test pass. And even though you know what's the next step, you don't go ahead and write the next step. You just write this step for that test to pass. Then, after a couple of iterations, you start having a bunch of code, and this bunch of code will get bigger, and there's where the refactoring part goes in. And with the refactoring part, you reorganize your code in order to follow some design patterns and remove some bad smells in the code.
Yeah, I've got a small anecdote here, is that the first step, the red step, is really important because I once forgot, and I coded some things for, 10 or a quarter of an hour, 10 minutes or a quarter of an hour, and in the end, the test were green not because I had fixed them, but because I had forgotten the add test annotation at the first place. So, yeah, the red phase is important as well.
So let's now talk a little bit about what are the benefits of test-driven development. The first one is less bugs, because we all know that the reason we have bugs, or actually the number of bugs would increase as proportional to the number of the code we write. So the more we write code, the more the number of bugs will increase. But with TDD, we are limiting the number of codes we are writing to the number of tests we have, or the tests we have written before, which means that this proportion, or this ratio between the test and the development or the code will drop down, and thus the number of tests will drop down as well. The number of bugs will drop down as well. Another point would be less debugging, because simply you have a test for each scenario or for each feature you are writing. So if you're starting from scratch, you write your test, you know the input, you know the output. If the test is still passing, you know the flow of the code, so it's easier to go and check the flow of the code instead of running the debugger. And if you have a production scenario, you can simply write the test for it, and then you can go through the flow of the code because you also know the flow of the code, instead of throwing some debugger points through a production scenario and going through the code one step after the other.
Yeah, I think after 1 year in our team, you'd have forgotten the debugger shortcuts. So I actually don't know them anymore.
Yeah, but I think with our team, we remember the refactoring shortcuts.
Yeah, sure.
Finally, the last point would be clean code, because we're saying here that we start with a test, we write the code that makes the test pass, and then we refactor the code. So this refactoring of the code will clean our code, will make it follow some design patterns and removing bad smells. Another thing with the TDD, with the clean code, is that if you have difficulty writing your test, that means your design is bad or needs improvement. So once you get to a point where you're not able to write the test from the first time, it's an alarm or a trigger that you need to refactor your code or reorganize your code. So you might be wondering what we have done in our team. There's a screenshot here. It's a little bit white. You can't see it that much. But what we've done, this is actually taken from Sonar, which is some kind of quality checker online tool that run the tests and makes sure that the code is following the standards we want. So in our code, we have 90% of our code fully covered by tests. We have 3.6 thousand unit tests written in our code. This is too much. I mean, just having our code 90% covered is really a great achievement for the team. One of the questions that might rise is, does it all work in all cases? From our experience, what we have noticed is that it absolutely works for any kind of application you are writing, whether it's small or a huge application. TDD would work in any place with such cases. But it might be harder to implement or use when you are writing a mathematical equation or a mathematical game. For example, if you take Sudoku, if you try to implement Sudoku using TDD, it would take you much more time rather than writing the standard way. Or actually, another way to write it is write a full end-to-end test for each scenario and then try to implement it and see that all the tests are passing.
You can also think about the algorithm you want to write and then only then start to add the tests in a way that will help you make sure you're progressing on that. But you've got to think about the algorithm first.
Right. The second question that might pop up is, do we have bugs? Well, yes, we do. We actually have a game at our team that we play, which is called exploratory testing. During that game, what we do is we run our engine or our database server, and we start playing around with throwing complex queries to the server. And then we wait it to fail. And the one who gets the most bugs will get some fruits for free. I'm serious. And then another source of the bugs would be the clients. The client would send us that this query is not working, or this feature is not working, and we do add them to our backlog. But the only difference between us and the other teams is that we don't tend to solve the bugs on the spot. What we do is we try to replicate those bugs in a unit test or an end-to-end test, and then we try to solve this unit test. By doing that, we guarantee that this kind of bug will never occur again in our code. So, the fourth or the third practice, I guess, is the pair programming. So with pair programming, it's very obvious that you have two people or two developers sitting next to each other, writing the same code. They are writing the same code all the time. So we actually do that at our team. One of the developers, the one who has control over the keyboard and the mouse, is called the driver. And the one sitting next to him is called the navigator. And his role is actually to do a continuous code review to the driver and then try to brainstorm with the driver on what are the next steps to implement.
Yeah, and also the navigator is supposed to keep an idea of the end goal to make sure that we will be getting there.
Also, this kind of practice is also known as the 4 eyes principle, because as you can see, you always have 4 eyes looking at the same code at the same screen at the same time. So, like anything else or any other practice, there are some good points and bad points, or advantages and disadvantages. So let's start with the advantages. First, we noticed that with time, it's easier and the team learns faster. Why? Because you always have someone who's more knowledgeable about the topic than the other one. So they will always be sharing the knowledge between each other. And this leads to having the newcomers submitting from the first day. For example, a couple of months ago, Etienne, one of our team members, joined our team in Paris. And actually, he took a bug from the first day. Someone was sitting next to him. They coded together, and Etienne was able to submit from the first day. So in that case, he really feels that he owns the code, not just like someone who's wandering around. Or it might take him more time to do that if he's doing programming alone. The code quality has increased. The role of the navigator is always to do code review. In usual cases, or what you do is you push your code into the SCM, and then someone else would come review your code, either accept your pull request or request some changes to the code, request some modification or in order to follow some kind of standards. But with this kind of pair programming, the navigator is doing that job on the spot. So once you submit your code, there's no need for someone else to review because you are sure that 2 people are following the same standard at the same time. There was no impact on productivity. Some people would argue that having 2 resources working on the same code is actually a loss of one of the resources. For us, that was not the case. Why? Because, again, it goes back to the sharing of the knowledge. We almost at the team, we all have the same knowledge of the code somehow. And with that, there's no impact on the team if someone decides to leave the team or go for a long vacation. Anyone can take over at any time. And finally, one of the main importance of pair programming is that we end up with a bonded team. And this is actually, although we are in 2 offices, but we are a bonded team at the end.
Yeah, I just say something about the productivity. Is that I think in the long run, we don't have any figures to measure that, but I'm pretty convinced that in the long run, it actually made us more productive than sticking to a single solo program.
Yeah. Can you keep the questions till the end, please? If it's quick, but okay. One of the bad points or some of the negative points of pair programming is that it's tiring. It's really not easy for someone. It's not easy for the driver because he always has to talk what he's writing. He always has to explain what he's doing to the navigator. And the navigator always has to follow up what the driver is doing and sometimes anticipate what the driver will do on the next step. So he's always focused at the screen. This is really tiring at some point. It's also very risky because it's not all developers want to do pair programming. Some people, they just love solo programming. So in some cases, they won't blend in the team. But actually, in our team, what we did is we came up with some kind of pairing agreements. We did that during some of our retrospectives. Some of the pairing agreements we came up with is that we should always have respect to each other, no matter what. We should always listen to each other's ideas, even if you know that you are right. You should listen to your pair because once he said, because it's very possible that what he says will trigger a new idea or new enhancements for your code. We change our pairs every week. And again, no matter what is your relationship with your pair, sticking with the same pair for more than 1 week is risky. And rotating every week means that you are rotating or doing some kind of knowledge share between the rest of the team members. And finally, we do remote pairing if someone of the pairs or someone of the team members is sick.
There's something also, the first time you'll be pair programming, don't eat too much garlic. Your pair will find you.
Philippe, you don't know this, but there's a place in Beirut called Farouj Lala, I guess. If you do that, I think no one will remain in the office. Okay, the fourth principle is retrospectives. Ben Lenders is one of the speakers here, and he talks a lot about retrospectives. Retrospective is actually a meeting that we do by the end of each sprint or the beginning of each sprint, with the main purpose of finding out some obstacles or some kind of pain points we faced during the previous sprint, and then we come up with actions or tasks in order to fix them in the next sprint and make sure they never occur again. So you can organize your retrospective as you want. For our team, what we've done is we've divided it into 5 sections. We have the check-in, which is more like an energizer for the team members in order to get engaged with the current meeting and have the friendly environment to pitch in their ideas. There's a throwback activity during which we look back at what we did during the previous retrospective. We see what of the tasks were done and which were not, and we discuss why they weren't, and then come up with another actions to fix them. Then we move to the third point, which is the most important one, and which is collecting insights and discuss. During this activity, the team members are free to write in any points they want, whether it's a good point or bad point. We post it on whiteboards, and then we have a group discussion or a team discussion. Then we group the common points together, and then we vote to the most important topics that we want to discuss, and we move it to the fourth activity, which is the actions. During that, we have another brainstorming, we have another discussions, and we come up with actions, which we put them in the backlog of our team's backlog, and we take them for the next sprint to fix during the next sprint. And finally, we do ROT, which is a return over time invested.
It's also a famous French dish, so it's always making, it makes French people laugh. It's not very good.
By the way, you all will be you will take part of ROT for this presentation. ROT does not have to be done only for meetings. It can be done for any event that happens. So, for example, probably Xavier, I, Philippe, Muhammad, and Hisham will do a retrospective next week to evaluate what we did during this Agile tour, for example. And in that case, we come up with what we need to enhance and what went well and what went wrong. So this is the last retrospective we had. In that case, Muhammad and I were in Paris, and we had a local retrospective with the guys in Paris. So you see here, there's a glass board, not a whiteboard, but we have all the post-its. Philippe, you're still there, right? Yeah, we lost electricity, so they can't see you anymore, but they scare you. Welcome to Lebanon. Okay. Philippe, do you mind if I continue?
Yeah, it's okay. It's okay. It doesn't change much for me.
Okay. Yeah. So here you can see all the post-its we had, and this is like at the end of the retrospective. So everything I've said so far, everything I said so far was textbook. Probably there is some kind of a taste we added to those practices. But what is important for us, or interesting for us to show today, is the next steps. 3 years ago, I joined the team from the Beirut office. The team back then, they didn't want to change their way of practices. So we decided to adopt those extreme programming practices to a remote mode. And so in that case, our pair programming had to go from local to remote pair programming, and meetings had to go from local to remote meetings. So let's start with remote pairing. This is Muhammad, by the way. So that was the easiest part. We had just cameras and headsets installed for each one of us in Paris and Beirut. We used to share our code using Skype or Link. And one of the screens would be for the code sharing, and the other one to see the other guy, or for example, in this case, Huang in Paris. So, okay. So as long as the connection was going fine, we had no problem with the remote pair programming. But we had other issues to worry about. For example, time difference. There's only 1 hour between Paris and Beirut, but if you sum up all the time for office hours, lunch breaks, you will end up with like 3 or 4 hours per day wasted with no communication between the pairs in Paris and Beirut. So what we came up with the solution for this is that by the beginning of any day, the pair would share their calendars with each other. They would build up an online document where they will list all the steps that are needed to finish a story. And then it's their responsibility to keep this online document up to date. So in that case, for example, if I was pairing for Philippe, and I had to leave 1 hour earlier than Philippe would just keep this online document up to date. And then the next morning, I would come 1 hour earlier than Philippe and continue from where he stopped.
Yeah, because when you're doing local pair programming, usually the navigator keeps track of the kind of to-do list to get to the end goal. And when he switches to driver, it just hands it to the new navigator. But in this case, obviously you can't do this, so we have to come with this online document idea.
Getting lost. It's a developer's intuitive to keep the keyboard under his hands. Like, he just wants to keep on programming. And when you're doing that with if I was in Paris and doing that with Philippe, for example, I just simply can grab the keyboard and continue on his behalf. We just argue a bit and then we settle it down. But when doing that remotely, it's impossible to get the keyboard from him. So it gets frustrating, and at some point the navigator would just lose focus, and he would just be daydreaming. For that, what we decided to do is to do a driver switch every now and then. So every 20 minutes, we would shelve our code or submit the code if possible, and then we switch the control. So the driver becomes the navigator, and the navigator becomes the driver. This kind of technique is also known as Pomodoro technique, which states that every 20 minutes you take a short break, and then after a couple of cycles, you take a longer break, like for 15 or 20 minutes, and then you come back to work. Getting tired. We said that pair programming in general is tiring, but with remote pair programming, it's even more tiring. Imagine now you can see Philippe that he has a small earphones on his in his ears, but usually we have a headset on our head all the time. So it's like, imagine you having a headset for more than 10 hours a day, listening to what people are saying and looking at screen, looking at what others are doing. This is really, really tiring. And at the end of the day, you might have headaches a lot. And by the way, Philippe has customized his headset. He has like sponges all over his headset in order not to have headaches. But the last one we want to talk about today is, in terms of remote pair programming, is the code sharing. So again, if I'm sitting next to Philippe doing some code review for him while he's writing code, I would simply just point out my finger on the screen and do like, yeah, you missed a semicolon here, or you should put an integer here instead of a string. But when doing that remotely, I was just pointing on my screen. He has no idea what I'm saying. If I tell him, like, put a semicolon here, he's like, what the hell is here? And so just let me know where is here. So this is somehow funny, but it's also, in some cases, it's frustrating. For that, there's a lot of new tools that are being implemented. There's Flubits, for example, and there's Saros. Unfortunately, we were not able to use both. Flubits, we had some kind of IP problems with them, and Saros is only implemented for Eclipse and not for IntelliJ.
Yeah. There's one thing great though about remote pair programming is that you can come to work in flip-flops if you want. Your pair won't notice. So.
But just last reminder, you're working from home, right?
Yeah, today actually, yes.
Yeah, please don't move the camera, I guess.
Yeah.
Okay. Philippe, how about a demo?
Yeah, I think that would be great. That would be great.
Okay.
I think everything is set up, and we can demo Fluebits and doing some small remote pair programming with Fluebits. So tell me when you're connected. I think I'm on already.
Okay. I'm almost there, and it's going to be a bit difficult to reach the mouse because I have 3 screens. Okay.
I was thinking of demoing FISB's kata in TDE, at least the first steps, just to show how to do remote pair programming using TDD and what the tools like Fluebits can give us.
I'm just trying to connect to Fluebits.
Yeah, I can see you. Here you are. So, can you see the instructions?
Just 1 second. Yep.
Yeah, can everyone see the instructions as well?
Unfortunately, we have a problem with the scale. Okay, just like, okay, no problem. Yeah, okay.
It's okay?
Yeah.
Okay, so do you want maybe I can just quickly summarize the rules of the FISBIT. So FISBIT is a game where you want to count from 1 to 100. So it usually plays at many people, and we've got to count one after the other. And so the idea is that whenever you go to, it's your turn, you should just say the next number. But if ever the number is a multiple of 3, you just say FIS. If it's a multiple of 5, you'll say BUT. And if it's a multiple of both, you'll say FISBIT. So here what we're going to do is we're going to write the first steps of this program, which is not very hard, using TDD. So I write the first test, Ahmad, and then I'll let you fix it.
Yep, that's good.
So I guess you can see me typing on the screen, and the big void, so let's call it should return 1 when given 1. So I think it's a pretty first step for the TDD. And what we'll do here is assertions dot assert that FIS buzz dot of, for example, 1. So I'm writing the test as if the code was there, is equal to 1. So that's it. So it's complaining that the off method doesn't exist, so I'm going to create it. It's going to return an integer for the moment. It takes an argument, and I'm happy with returning 0. So it's the test. So the test seems to be compiling. So let's run the tests. So with Fluebit, we can sync the changes to the files, and we can see each other's cursor, but we can't sync running the tests. So I think Ahmad and I will both have to run the test.
Yep.
So it's failing on my side, Ahmad, so I think it's up to you to fix it now.
Yep.
It's your challenge.
So this is just a simple problem. So what we're going to do is we're just going to return 1 here. I know it's stupid. It's easy, but just we're showing you how we do some work. So now the test is green. So the next step we do, remember that we usually do this in advanced stages, but we're just, for the sake of the demo, what we tend to do next is doing some refactoring to the code. So what I can see here, Philippe, let me know if you don't agree. So I can see here there's an I, and for us, an I is not a valid name. So what we do is we name it like, for example, a number. And in this case, we run another test because we did some refactoring and we want to make sure that the test is still working. So that's great. We also, another enhancement is that this is public, so we should make this private because it's only being used in the test. So again, we do that and we run our test. So it's green, so we go on with the second test. Probably we can just like say what's the next test instead of demoing it. What do you think? Or
I think we'd like to get rid of this hard-coded 1 here. So.
Yeah, we can write another test. Let me write another test for you, and then we can end it there. So the next step would test would be if I'm sending 2, I should get a 2. And in that case, this one. So this would be 2, and this would be 2. So now if I rerun the tests, we're going to see that one of them is failing because there's a 2 and a 1. So now I'm going to leave it for Philippe to fix it.
Yeah, I think this one is, I can deal with this one. The challenge, I'm just going to return number instead of 1. And if you run the test, and on my side they're passing.
Mine too. So
okay.
That's great.
So I don't know if there's any more refactoring to do here. Can you spot anything?
Not for me. I think that's fine.
Yeah.
Oh, I think there's only one thing we can do, but yeah, it can be really fast, which is we can see here that there's a duplication in the code. Do you want to do it, Philippe? There's a duplication in the test, so we can.
I'm extracting a method called fizz.
Okay.
That's it. I'm moving it down, and what I'm going to do is extract arguments parameters here. So I'm extracting the first one as number, and the second one as the expected value. So here it is. And IntelliJ is asking me if I want to replace all the possible usage of this method. That's what I did in here with this final code. I run the tests, and they're passing here. And I think that's it for the demo.
Yep.
The idea is not to go to the end of the business, but rather to show you how you can do TDD in remote parallel.
Okay, so let's move to the second point. So we talked a little bit about retrospective, and we said that the main hardware to be installed in a retrospective, let's say, is a whiteboard, and that's what we usually do when we are in Paris. But when I started working from Beirut office, initially the whiteboard was still in Paris. So what I would do then is write my comments, send them to Philippe over link or Skype, and then he would take care to write those comments into a post-it, and then post it on the math. Mainly it was usually in the math part of the GladSat math activity. And then Thomas, another team member, would take a photo of the board, would take a photo of the team members and email it to me and Muhammad to make sure that we are still bonded with the retrospective activity. So we decided to change that, and we started looking into some kind of online tools that would replace the whiteboard. And eventually we started using Trello. And Trello is an online tasking tool, which is not a replacement of whiteboard, but so far it's doing the job. So you'll see in a bit in a demo that Philippe and I are going to do. We both coordinate at the same time. We both write our comments at the same time. So eventually we went from MAD to SAD to GLAD, and that's our current state. One disadvantage of Trello so far is that it doesn't cover all the activities of the retrospectives. For example, the 5 whys would be hard to implement when doing the remote retrospectives. The second point with remote retrospective is the visualizing the other team. So I was here in Beirut, Muhammad was here with Beirut, and we couldn't hear anything, we couldn't see what's happening on the other side. So to tell you just a short story, one of the times our previous managers came to Beirut, and he attended the retrospective with us. Before 40 minutes of the end, before the end of the retrospective in 40 minutes, he decided to leave the meeting just to do an experiment. And guess what? No one in Paris knew about it. They thought that he was still there. They were still talking to him without him replying, but they had no idea that he wasn't there anymore. So this was actually a trigger that we needed to change something as well. So with the help of the Murex IT team in both Paris and Beirut, we managed to install a video conference setup in almost most rooms in both cities. And as you can see from the screen now, we have one screen dedicated for wiki sharing or screen sharing, and the other one for video conference. So we can see each other at any time. We did not stop that there.
Come on, Ahmad, it happened again. You forgot, I went away, you didn't notice. We've got to work on it.
Oh, yeah, I forgot that, sorry. Sorry, Philippe. Yeah, so actually what happened now, Philippe was not on the screen. I had no idea. I was not looking at the screen, so I imagine like there was no screen, and I had no idea. That used to happen a lot in our meetings. Now it doesn't. And now actually we're having remote lunch between Paris and Beirut. And this is actually one of the remote lunch. Muhammad was the guy here. So he was in Paris, and they all bought some lunch to a meeting room. I was sitting on my desk, and we had remote lunch and remote discussion. So another demo?
Yeah, Trello this time. So I set up a board, a sailboat. So the sailboat, while Ahmad is talking, I'll just explain the sailboat. So the sailboat is an activity to gather insights about what happened during the last sprint or iteration. So I'll wait for Ahmad.
Yeah, I'm logged in.
Can you all see the Trello board?
Yeah, it's on the screen. Okay.
So then you can see that there are different categories, and they're all around the metaphor of the sailboat. So for example, there's the land, which is what we want to work to accomplish, the wind, which is pushing us, the bad waves, which are difficult for us to cope with, and the incoming dangers, which are found. There's also something we added, which are plugs and kudos, for things we'd like to just find people about. So with Trello, we can all add cards independently from each other. So that's what we're going to do right now. So it really feels like a whiteboard where everyone can stand up and stick post-its on it. And you can use the ideas of others to come up with new ideas.
Okay, I'm done, Philippe. How about you?
Still working? I'm done too.
Okay, so this is the activity, the third activity we talked about in the retrospective. So here we're collecting some ideas and feedback from the team members. So what we do next is we usually discuss each one of them, but we're not going to do this today. It's not the purpose. So what we do is we usually vote on the bat and the clouds section. So for example, first we group them. So we see that there's a connection and the internet connection going together. There's an electricity and someone starting to do a lot of noise in Paris. So we tend to vote for those ones. So let's take 2 votes each one, and then...
maybe we could group. Did you group the connection?
No, I forgot. Okay. Yeah, it's easier for you. I'm working here.
Yeah, sure. So what we do usually is that we group things. So Trello is not really meant to group things. So we create some kind of marker counts for that. And then, so shall we vote?
Yes. So here you can see I can vote. And let's say I'm going to do for electricity and vote. And then, so here you can see that both of us voted on the connection and each one of us voted on another issue. So the one with the most vote goes to the second point where we discuss the actions and we take them into our backlog. Okay, I think it's time to go back to the presentation. Okay. Sorry. Okay. So now, how about we look at the questions. Hopefully this would work. Just 1 second. Okay, so I'm gonna just switch back to the ID. Okay. Okay, so Philippe, you want to?
Yeah. So I can see is pair programming done in specific types of tasks, or you adopt it all the time in all tasks? I think we kind of adopt it all the time. Sometimes we've got some slack time at the end of the iteration where people kind of either work on finishing things that they're interested in, or learn new things, or experiment new things. And on these tasks, it's up to anyone to decide whether he wants to work in pair programming or not. But the thing is, all production code is written with at least 4 eyes. That's the thing.
Okay.
Shall you answer the next one, Ahmad?
Yeah. So, what's your take on the tiny overhead of test development for? Sorry, who posted this question? Yeah. Can you just, because I can't see the rest of it.
So let's say you have a small project that needs a very tight schedule to deploy. Is it worth the overhead of doing custom development, or like when you're talking about risks and talking about planning ahead? Would you take into account the overhead, or would you do it regardless?
First, if you want to think of it just like that tests will take time from your development, that's true, because you're putting some time for tests. But if you think of it at the long run, you're actually eliminating some bugs from your code. So if you started from scratch doing TDD, you should allocate some time for the testing, because it will benefit you later on. So if you, for example, in our team, we started with many bugs. We didn't start everything from scratch with TDD because the project was started before we joined. So when Philippe joined, he started doing the TDD, and then bit by bit our bugs started going down. So I would say always start with TDD.
There's something you can do at first when you start your project that it's small. You can use automated but end-to-end tests. This way, your build will still be fast because the code is small, and so the test will run fast. You'll have a good coverage, and you'll be able to, little by little, add more unit tests as you go along. But it's rather advanced, to be able to know when you need to add these small new tests. So it's something you can.
Small follow-up.
Yeah.
Do you apply TDD for existing systems?
Yes. What you can do actually, you just have to keep in mind that you will not be able to reach full coverage of your code, or like high coverage of your code for an existing system from the start. You have to do it incrementally. So first thing to do is at any new development you do for your existing system should be following TDD. This is the first step. The second point is refactoring. When you want to do refactoring, you should write a test before doing the refactoring. And you start from those 2 points. Bit by bit, you start refactoring your old code in order to have your full code covered with tests. There's a blog I wrote as a summary of one of the books I read on XP. And actually, it was an interview of one of the senior managers at an airplane company. They do softwares for airplanes. And when he got to the company, he had, I think, 300 employees. They were doing no TDD. They had a lot of legacy code. And he was able to apply the XP with full TDD in the teams. So I encourage you to read the book at least. You can look at the blog and see what's the book. And for that, he really has good answers for that. Philippe, I think we'll go to the last slide because we're done. We're almost out of time. Just to let you know that if you have any questions, you can ping me around when you see me. It's fine. So the last slide for today. So at Murex, the remote teams, the remote work is increasing. We have more and more teams starting in Beirut, and they are reporting to Paris. They might not be doing extreme programming as we are doing now, 100% as we are doing. But remember, Agile is flexible, so you can adjust it as you want. But we are sure that they are doing remote pair programming from time to time for code reviews at least.
Yeah, well, what I would say about the flexibility of XP and Agile principles is that they can be adapted pretty well on remote settings. For example, if you've got only a few places with enough people in every place, you can just have different teams. If you've got like the open source projects, people spread all over the world very far, you can switch to some kind of pull request based asynchronous process that will work fine. And if you're in a case like we are, where you've got only a few people in a few different places and not enough to do many teams, you can just push XP to be remote, and it works.
Okay. So just two more points. First, after that presentation, I'm gonna reactivate a survey at the same website you saw previously. Sorry, I said this is so this one. So please, like in 10 minutes or 15 minutes, I'm gonna leave it till the end of the day. So just be part of the ROT and give us your comments. Last message is that if you can work in Europe or the Silicon Valley while eating manouche every day, so you don't have to fly abroad to work. Finally, thanks for our sponsors and the partners that made this tour successful, and thanks a lot for your attendance. And if you have any questions, please stop by. Thanks.